rational and integer. Since it's a rational exponent, and before that we were dealing with the integer exponent. So what's the difference between rational exponent, forget about exponents. So what is rational and what is integer?
Fraction. So
yeah, rational is a fraction or a decimal, right? Where integer is a whole number. So when you were working with this individual like classwork, right, independent classwork, if you remember now, all your numbers were whole numbers. But are they both positive and negative or only positive? They're both negative and positive. So integers are whole numbers, both positive and negative. Now we're moving on to the next level, which is the rational exponent. Yes?
May you please post the notes after the class, because sometimes I forget to...
Yes, I know. I will try to do my best not to forget today. Okay, so rational exponents. Okay. Rational exponent is actually the same thing as a radical sign. Okay, so far, what I mean is, so far, the only radical you are really familiar with is what? Which one? A square root. So square root is the radical which you are familiar with. And what is square root of 16?
4.
4, okay? Which is which number raised to the power of 2 gives us 16. Now, square root of 16 is exactly the same thing as 16 to the power of 1 over 2. Okay, now if I have a different radical, because square root is not the only radical out there, you can have different radicals, infinite amount of radicals. For example, if I have a radical which has a number here on top of this part of the radical, for example, 3. Okay, then let's say I have 27. Okay, what does this mean? It means the same thing as 27 to the power of 1 over 3. By the way, what is it? What is third root of 27? Which means which number raised to the power of 3 got you 27?
7 or 9.
This can be easily checked on the calculator. So I want you to see now, to find on your calculator in yellow and golden color, you have the third root. So if you press
3 multiplied by 9.
What is 3 multiplied? Third root of 27. Can you put it on the calculator?
27. Then
9 over 3.
3. So please make sure that you found this on the calculator. Third root on the calculator. Third root of 27 is 3. Okay, so
isn't
what I'm
radical, like, isn't it 9 radical and then the 3?
What is 9 radical and then the 3?
Like you do the 9.
Yes, I got the same.
You do the 9 and then you do the.
Then the square root, he means.
Yeah, square root.
You put the 9 and then square root.
Put 9. Miss?
No, Miss Nus, I think I know what he did.
You mean square root 9 and then times 3?
Just on the calculator first.
Times 3.
9 is out.
Guys, look, forget about it. Don't go in this direction. You will be confused. So right now, just follow my logic, okay? So if you have square root, it means that you have 16 to the power of 1 over 2. If you have, now we call it third root or cubic root. So if you have third root, because it's the third 3 here, it means that it's 27 to the power of 1 over 3, and so on. Now, finally, if you have a number, let's say a is a variable, okay, and I have here, for example, 3, index 3, and here I have and here I have number 2. This means that it's a to the power of 2 over 3. What I'm trying to say is that a radical and rational exponent is the same thing. So we can write the same idea in the exponential form. So you can use the rational exponent or radical. It will be the same thing. Let's double check that. I want you to use, again, your calculator and put 27 to the power of 1 over 3. And tell me what will you get, what will be your result. Take 27, then press power, then instead of power, press fraction, and then put 1 over 3.
3, miss.
What?
I got 3 for 27.
So you should get the same result. So this is the same thing. Now, a couple of things about terminology. Okay, so this number, which is on top of the radical, is called index. If you want to use if you need to use plural form for it, it's indices, like vertex, vertices, okay? So this is the number on the left of the radical sign. It tells us which root is indicated. 3 for cube root, 4 for fourth root, and so on. You can say third root, fourth root, and so on. If there is no number, then it means that it's a square root. As you saw before from the example here, right? You are used to this symbol. This symbol doesn't have any index here written. It's by default the second root. So, and there is no first root. So it's by default the second root. It means that index 2 is something that we don't write, we only mean it, okay? And then all the other indices, we are supposed to write them down. Now, to make a conclusion about that, so how to switch between the rational exponent and the radical. So as you can see here, if I have a rational exponent, m over n, and I want to switch to radical form, then n goes, which is the denominator, goes always to the index. And m is next to b. It can be written either under the root, or you put everything in the brackets and put m outside. It's the same thing. I'll give you an example now, and then you will ask the questions, okay? So for example, in this case, I can a to the power of 2 over 3. So 3 is the denominator. It goes to the index. So 2 is the numerator. It applies to a. So you can write it like this. But this is the same thing as third root of a all squared. This is the more commonly used, but sometimes you need to recognize that this is true. Let's verify that this is true using an example, okay? For example, let's take any number, let it be something not big, 2, and then the power of 2 over 3, and then we apply, which root should it be? What is the index? If I want to write it in radical, what should be the index? 3 or 2? 3, index 3, and this is squared. So I want you to put this expression on the calculator. What will be the result?
I got 1.5.
1.5 and then what?
Yes, I got 6.
1.58.
Yeah, exactly.
5.8.
Yeah, I
1.5.
got 1.5.
How did you do it, Farah? I don't know. 2 squared. You can, if it's difficult for you to write it like this, you can, instead of 2 squared, you write 4. So it's square root of 3. But 2 squared, you should write 2 and then the exponent and then type 2 in it. I don't know what you did wrong. So 1.58, right? Now let's try inputting it differently in the calculator. Third root of 2, all inside the parentheses, squared. Can you do that, please? Exactly like this. Third root, it's shift, right? Shift square root of 2. So you get the same thing. So that was my point, to prove to you that whether you are writing the numerator of the rational exponent next to a under the root or outside the parentheses, it means the same thing. Do you have questions? No.
Yes,
Good.
miss, I have a question.
Yeah. Mhm.
About the example for A, is that the 3? So the index is 3?
You mean this one?
Yeah.
Yeah, it is 3. It's not clear, right? I'll put 3.
It wasn't really
Yes,
clear.
so all what you need to remember, my recommendation is that the denominator goes to the index. That's it. The rest will be easy. Then the numerator doesn't have any option but to go to A here under the root. Okay, so what's nice, the good
Miss, can
news
you
is
repeat?
that always
Miss, can,
stick to the idea that the denominator of the rational exponent is the index. So denominator becomes index always.
Thank you.
You finished everything, right? Okay. So the denominator becomes index, all right? So, and then this will make your life easier. So let's go back, and before we start applying everything, a couple of other things to say. Well, first of all, whether you are dealing with the integer exponent or rational exponent, the rules will stay the same. This is the good news. The zero exponent, the division, multiplication rules, and power over power are going to stay the same. Just now, you're going to deal with the fractions when you add, subtract, instead of the integers. That's it. There are a couple of things which you need to know is that can I square root a negative number? For example, if you put on the calculator square root of -4, what will you
Wouldn't
get?
it be a positive?
Can you try? Square root of -4. What are you getting on the
Error.
calculator? Error.
Error.
So it's impossible. Impossible. So the idea is if the index
Sorry, miss.
when index is
Okay.
even, the number under the root cannot be negative. The number under the root cannot be negative. Under the root can't be negative. Okay? However, what if let's explore index which is not even. Which index will not be even? Give me an
3?
example. 3. So let's say third root of -27. Put it on the calculator.
I think that was 9.
9. The third root of -27.
I
On the
got the
calculator.
error.
Third root, you did something wrong. Third root of -27.
Yeah, I did third root of -27.
Third
Miss, I got
root.
-3.
Of course, you should get -3. I don't know how you got error. Okay, so
How
third root.
how do we input the 3, miss, into the
So it's
calculator?
Fifth.
No, you don't input the 3. Look, I'll try to show this on the camera. I don't know if it will be. Look, you need to
3 over 1?
use this one. Look, this one, it has already 3.
What's it written as?
It's a square root, but if you press shift square root, it will be the third root automatically.
Oh, shift
Got it?
square root.
But generally, you need to know any how to input any index. That's why we have another button. Where is it? This button which has got X with the box. It means that you can input any power, right? And if you press Shift, you see here in golden color, it has a root with empty box instead of the index. So you can input any index there. We'll try practicing it today. All right. So
Miss, can you just show me what you wrote in your notes?
So conclusion, yes. Conclusion is that if the index is odd, the number under the root can be negative. Under the root can be negative. And why does it make sense, guys? Who can explain? Why does it make perfect sense? Because square root, I'm thinking which number raised to the power of 2 gave me something. Raised to the power of 2 gave me -4. Is it possible to square something to get -4? Of course not, because even if this number is -2 and you multiply it by -2, it's going to be +4, not negative.
Well,
But
so
if
3 times the negative, and
but
positive.
exactly, but if you remember, if you multiply odd amount of negative numbers, you will get negative results. So something to the power of -3 is can be -27 because it's -3. Sorry, not negative. Sorry, not -3 here. Something to the power of 3, -7, 27. So it's -3 times -3 times -3 is -27. So it's okay. So that's why it makes perfect sense with odd and even. All right. Yeah, that's it about like theoretical part of this lesson. So I would like to start practicing some of the questions with you. All right, so page 229, I already mentioned that. So the exponent laws for rational exponents is going to be exactly the same thing. So I'm going to jump directly to practice. Page 229.
Are these questions due or?
We will, just a second, I'll open the questions and I'll tell you which ones we're going to do. But page 229, and the range is from 1 to 14, a big range of questions. So we'll do something now, 229, okay? So this is a big range of questions. There is a lot to do. We'll probably, I think that we are going to the rest of the lesson, we're going to work on them, and then I'll ask you to do it at home, and then if you have still questions, we can do it tomorrow as well. All right, so...
Miss, all of them will be due at home?
I'll tell you later, okay? It depends on the dynamics. I'm not able to tell you now, because I don't know how it goes. If you're getting it, if you're not getting it, so I'll see by the end of the lesson. All right, so we'll do a couple of examples, or like one example, 2 examples from each one. So first of all, we need again to practice reading the question to understand what the question was from us. So read the question and tell me what should be the first step and what should be the second step.
Miss, they want us to write it in radical form.
So in radical form, it means, for example, let's take 16 to the power of 0.25. In order to write it in radical form, we need to have a fraction, right? Because
Yes.
the decimal, you cannot link decimal to the radical. So what fraction can you replace 0.25 with?
1/4.
Exactly, 16 to the power of 1/4. Now you can write it as a radical. So Selim, what will be the... What is
2. 2.
Why 2? What is the rule
The answer is
about...
2 because...
Where does the denominator go? You need to write it in radical form. You didn't write it. Where does the denominator of the rational exponent go?
It goes before the root, like...
So instead of... It becomes index. So root... Here's the index.
Answer.
No, that's why I told you, read the question. The question says write in radical form. So this now is the radical form. And then you can use the calculator and then evaluate. Okay, let's use the calculator because I want you to practice how to use the calculator. So practice using the calculator for the 4th root. So what are you getting? What's the answer?
I don't know how to input. I don't know how to input index.
You don't know how to input index.
It's 2.
Again, do you have the
Yes, it's right in front of
you
me.
have the calculator in front of you?
Yeah.
Okay. So look, there is a button just under the big button, which is X
Which-
and then box. You see this?
Yeah, okay.
So if you press this one and shift, it will be the root with the box, with the empty box. Do you see that?
Yes.
Okay,
Press shift
so
first, Tony.
now instead of this empty box, you can input whatever you want.
No, it's in front of me. I put when I did it. So
Listen,
do we press
You
root
put
and
shift.
shift at the same time?
لا you do shift الأول. Shift
Yeah,
first and then
shift.
press.
Shift and then the button.
Yeah.
yes.
Oh, okay.
Got
This
it?
is-
Yeah.
yeah.
Okay. So fourth root of 16, guys. What's the answer?
It's 2.
2.
Exactly. It's 2.
Yeah.
So
Yes, it's 2. You just need
So
to
you
do the
want to-
steps because we are practicing or drilling specific skill, which is switching from the rational exponent to radical. Number 2, using the calculator because those are the new buttons for you. Okay. So the answer is 2.
yeah.
Okay, let's do one more. Very important. F.
Sorry, miss. The inch is 2 for A?
No, it's D.
Oh, okay.
Right. F negative usually becomes a problem, right? Students don't know where to put it, so I want to discuss it. Minus 144 to the power of 0.5. First of all, let's switch to the fraction. So which fraction can you replace 0.5 with? What is the corresponding fraction?
1/2.
1/2. Now, now I'm going to switch to radical form. Where do you think the negative will go?
Where is the negative? Oh,
Here,
that.
from the very beginning. Where will it go?
Yeah. I don't know personally. It will go in the 2, so -2. So the index would be
Of course
-2
not.
and then
So of course not. Okay, so that's why I focused on this. So look, guys, what is negative 144 to the power of 1/2?
Miss, wouldn't
You
just-
have to see two things there multiplied. What are the two things multiplied? -1
and 144.
and
Oh no.
144 to the power of 1/2.
Wouldn't you just distribute?
What is distribute? No, you're not distributing anything. I want you to understand that this -1 is a factor in the product which is independent and has got nothing to do with the second part. Okay? So it means that when I'm doing the radical form, its minus comes first and it's alone. It's not related to what's going to happen after. Okay? And now I'm going to write the radical. And you tell me what is going to be where will denominator go?
Index. It will become the index.
So shall I put index 2 here?
-2.
Of course,
do
not
it
-2.
No,
Negative
miss.
is here. I'm asking, should I put 2 here?
Yeah.
I don't know.
No.
No, you should put
Why?
-1.
Oh, because I understand that we flipped the fraction. We flipped the fraction, so it
We
becomes
don't
now the
flip
numerator.
anything. It
No,
becomes
so
this
it'll
one
become-
becomes index. This one becomes index. Okay, I will write it here. But so this is how we switch. But do we write the index for square root?
I don't understand anything.
No, we don't. So we don't write the index for square root. So this is the radical form of this rational exponent.
Why did you take out the...
I didn't understand the last step. Why did we remove the 2 on the
Okay, I'll ask you now again the same question. So if you have a to the power of 1/2, how can I write this one in a radical form?
A 0.5?
No, 2
Is
and then
0.5
No,
radical?
2
no,
and
my bad,
index
miss.
and then like A.
2√A maybe?
Okay, let's go back to the presentation. Here. Read this part. If there is no number, the square root is intended. What does this mean? It means, yes, like by pattern, the way we do it, This is the second index, right? The second. But second index means it's a square root. In square root, we don't write 2. We write it square root of a.
Isn't it the same thing?
It's the same thing, but we don't write 2. It's
Oh,
not.
I understood, miss.
You got it? So we don't write 2.
No, I don't understand.
So square root is the only root where we don't write the index. Like, for example, Selim, x to the power of 1. You don't write it. You write x, right?
Yes.
But you
So I have a
assume, by default, you know that it's power of 1. So the same with the square root. Square root is index 2, but we don't write it. So this and this
Oh, I
is
understand.
the
No.
same thing.
So always so if it's above index 2, then we would write it.
Exactly.
What if it was index 1?
We don't have the first root. There is nothing called first root.
Okay.
Okay? So we start with the second root and up all the whole numbers. But the second root, we don't write the index. All right, guys? So back to the question. Negative square root of 144. I want you to use the calculator. Well, or maybe you know that 144 is a perfect square. So what's the final answer?
12, I think.
12.
Negative 12. Negative didn't go anywhere. It's still there, right? Negative 12. Any other questions about F?
No, miss, I understand.
All right.
Is C the same thing?
C? What is C?
Yeah, because the negative inside the bracket.
No, it's not the same thing. We'll discuss it. Guys, I want to ask you, do you need 4 minutes break or we can just continue?
No, continue.
No, we can just continue.
Okay, good. Let's do C. It's good that you noticed that C is a different story. Well, it is, I mean, you noticed that there is negative there, but you didn't notice probably that it's a different story. So C is different. And why is it different?
Because the negative is inside
There's
the
already a
bracket.
fraction.
Because the negative is
Exactly.
inside, exactly. So if the negative is inside, so the parentheses in exponential function or exponential expression mean everything. I'll again give you a smaller, like a simpler example. For example, what is negative 2 squared and what is negative 2 squared?
Negative over 1 over the first one.
Just no, forget about it. Just evaluate the evaluation. I'm talking now about negative, the significance of the
The
parentheses.
first one's going to be equal to negative. The second one's going to be positive.
Exactly. Why is this the case? Do you know?
Because you're multiplying.
Because
Because
there's
you
a bracket to the
Here
power.
you multiply negative 1 by 2 squared. So because there are no parentheses here, it means that the square applies only to 2. It does not apply to negative 1. Okay? Here, parentheses shows that what are we squaring? We're squaring not negative, we're squaring negative 2 altogether.
Miss, where'd you get this from? The
This-
negative 2.
This is from my mind. I'm trying to explain to you the significance of parentheses.
Okay.
So you see that if the parentheses are there and the negative is inside, it means that the power applies to it as well. Okay, that was my point. So let's
C
go.
would just be 5 positive.
So let's now work with this question. What is 5 positive?
So it's index 12.5.
So it means that minus is attached to 125. You cannot put it in front of the radical like here.
Miss, I did it.
It will go with it. Okay, so let's switch to the radical form. What kind of root is it going to be indicating? Index 3.
Miss, on the test, do we have to
Index
do
3.
this?
So third root of negative 125. Emery, what's your question?
Do we have to, like on the test, do we have to show this or can we just do it in the calculator?
You will have to know how to do it because there are specific questions where calculator will not help.
Oh,
Okay.
okay.
Negative 5, miss.
So now put this on the calculator because there are questions where I will be checking that you know how to switch between the radical form and rational exponent. So what's the final answer?
It's negative 5.
Negative 5.
Negative 5. Okay. So done with 1. Let's do something something from 2. I suggest let's do F. 2F now, okay? 2F.
What does the question ask for? Must it turn it into exponent form
Let's
now?
read it. Let's read it. Number 2F. Good question. Write in exponent form now, then evaluate. So this is the opposite process. You see that all the questions are in radical form. You need to switch to the corresponding rational exponent. And then express in rational form. What does this mean? It means that it should be positive exponent. It's a must for the final answer to be a positive exponent. So you will not evaluate. You will only switch to the rational exponent and then make sure that this exponent is positive. Okay, so let's do F. So if I have fourth root, and then under the fourth root, I have power of -1. Which rational exponent is this corresponding to?
Can you say again, miss?
So we have a fourth root in F. You see index 4, and under the root, there is -1. So which rational exponent is it corresponding to?
1/4?
But why did you disregard negative?
-1/4.
-1/4, of course, because the index is always denominator, right? And -1, in this case, will go to numerator. So let's write it down. So it's going to be 16/81, parenthesis, everything to the power of -1/4. So we did the first part of the question, which is we converted or like switched from radical form to exponential form. Now we need to express it in rational form, which means positive exponent. So how to make this exponent positive?
We would then do
Reciprocal?
So what will be the reciprocal? Reciprocal of what? Emre, you got trapped. Because yes, I know the students want to reciprocate exponent. I don't know why. What was the negative exponent rule? You missed it at the beginning. What does the negative exponent rule tell you? What do you reciprocate? What do you reciprocate? You reciprocate the base, not the exponent, right?
Okay.
So what's your base?
So you reciprocate. So you do 81 at the top, or over 16, and then normal -1/4.
What was the point of flipping it?
4/1.
Positive 1/4, right? So since you flipped, now the exponent became positive. Okay?
You don't also flip the exponent. It should leave it the same.
You don't put what?
You don't flip the exponent also. You just take out the negative.
Yeah, you just remove the negative. So because you flip the base, your exponent becomes positive. You never flip exponent. Okay.
Also, it wouldn't become the power of 4 now, right?
It will not become power of 4 because the only thing which will flip is the base. Exponent switches from negative to positive, but it does not become reciprocal. This is what he's asking. So no, we don't reciprocate exponent. We only flip the base. Okay. Let's do it again. Something like similar with the negative. I don't have any other negative powers here, so let's do something in 3. Write it as a single power. And I'm telling you, whenever you write it as a single power, you have to make sure that the power in the final answer is always positive. So let's do D. 3D. Okay, so 7 to the power of 5/6. And all raised to the power of -6/5. Tell me what are we going to do to the exponents in this question? Since it's a power over power, what should we do to the exponents?
Distribute.
We are going to do what?
Multiply.
Distribute.
We are going to multiply them. So 5/6 times negative.
I thought, miss, we were gonna distribute the exponent into everything in the bracket. So like
everything in the
power.
bracket. What is everything in the bracket? You have only 7.
Oh, it's not the power of a power, right?
Okay, it's a power. 5/6 is a power. So power over power. If you have more than one term inside, then you will distribute it among all of them. But here you have only 7, right? Okay, so you multiply. When you multiply 5 over 6 and 6 over 5,
Negative
what will
1.
happen? It becomes negative 1, exactly. So 7 to the power of negative 1. Now, we cannot leave the answer like this, because we always have to have the final answer only with the positive exponent. What to do?
1 over 7.
Miss 1 over
1 over
7.
7, exactly. 1 over 7. Good. F from 3. Let's do F from 3. We have several rules there, and we need to write it as a single power. Okay, in F, but it's easy, right? So if you look at the first part, what should you do to the exponents in the first part?
Add them.
Add them. And then what should you do to the last exponent?
Flip the multiplication sign and then 10.
What?
Miss, I'm sorry, you lost me after we flipped 81 over 16. Could you repeat, please?
We flipped 81 over 16, so instead of negative exponent, it becomes a positive exponent.
Yeah,
because that's why we were flipping. After that, we started doing question 3D, which is 7 to the power of 5 over 6 to the power of negative 6 over 5. So it's a power over power, so we need to multiply them. When we multiply them, this multiplication, you get negative 1. And since we don't want to have a negative exponent, you will just flip the base, 1 over 7. Got it? No? Okay, so we're going to do this one. So we said that here we're adding the base. And if I add the base for the multiplication, does anyone hear me? Can you hear me normally?
No.
Okay, guys. Sorry. So I'm recording. Anyways, you can then repeat this part. So this is multiplication. So we're going to add the powers. What do we do when there is a division?
You flip the sign, miss. You make a multiplication.
No, you're
Why not?
still in the rational fraction, in the rational function, but we are in the exponent function.
Okay, then
Subtract. Okay, so I suggest that we write it in a nice and short way. So
what does it
I
say?
keep
2 over.
just a second. So I keep the base, and then I take those two exponents and I add them. Negative 4 over 5 plus 1 over 15. And then the last one should be subtracted. Minus 2 over 3. You can do it like this. If you don't like it this way, if it's confusing, do it separately. Like first, in steps. First add up and get the number, and then from that one, subtract the last one. What was the question?
No, miss, I just wanted to see what's beneath the 2, because I couldn't see. The question is very small.
Okay, can you see it now?
Yeah, 2 over 3,
Okay.
I see.
All right, so equals 10. So I want you to do all of this on the calculator. So negative 4 over 5. Negative what?
Negative 7 over 5.
7 over 5. Okay, we cannot leave the exponent negative. What to do?
You make the 5 like like in front of the root. I forgot what it's called.
Miss, I got something else.
No. Guys, we're not going to do the
Miss, I got another. I got a different answer from Adel.
What did you get?
I got 0 point something.
Why did you get we want fraction? Okay, I'm going to check. Negative 4 over 5 plus
It's negative 7 over 5.
1 over 15
Yes, minus 2 over 3.
minus 2 over 3. 2 over 3. So it's negative 7 over 5.
How did you get that, miss? How it's right in front of me, I put it exactly the same.
Look.
ورينا حبيبي.
Is this what you did?
Miss,
And I put the 10 before it.
10?
You don't need
Which
to put the
10?
10. You're just adding the powers.
You, of course, exactly. You're adding only the powers.
Okay, yeah.
10 is not participating in this.
I
All right.
understand now.
Okay, so my last question, how to make it positive? We don't want negative
5 over
exponent.
7? 5 over 7?
Again, you want to reciprocate the exponent after all what I said? I said never flip exponent.
Of course.
Do we put it in a radical?
So, no, the question does not ask for radical. I'm asking
أمال يا miss.
how to remove the negative exponent.
Uh,
مش فاكر.
I don't know. Wait, let me
Square
check.
root. Miss square root.
Forget about roots. Negative exponent again
This
and
is gonna
again.
be 1 over 10 to the power 7 over 5.
Exactly.
So,
So
what?
you flip the base 1 over 10.
Yes, of course.
And then everything becomes to the power of 7 over 5.
Oh yeah.
This is how you get the positive exponent. You need to flip the base, okay? All right, 5 minutes left. I suggest something more difficult than that.
Miss, do you just put that in calculator when you get 1 over 10 seconds?
I think they didn't ask to evaluate. They didn't ask to evaluate, or they did. No. Here they said
What?
write as a
Just
single
like that?
power. That's it. They didn't ask to evaluate. But generally, you can just put it on the calculator. All right. We didn't do anything with letters. So we're going now to switch to expressions with the
يا لهوي يا
radicals.
مس. يا لهوي.
This. Okay. So from question 6, we'll do something from question 6, and you will see that it's not that scary. It just looks like this. Just looks scary. That's it.
طب ما نعمل F
I
بس.
mean,
Yeah, of course.
Yeah.
But let's do F if it's not scary.
Let's do F. Okay, let's do F. Okay.
I was joking. This is
No.
terrifying.
We have 4 minutes. Okay, we can. I want to do something. Okay, let's do quickly. C. Let's do C. So this is 236, question 6. Let's do C for a start. Because I told you I am doing it today and tomorrow, so it has to come gradually to you. So we'll do 6C. So 6C, page 236. Number 6C. Page 236. Right, quickly. I just want to check what they want from us. They want to simplify, express answers with the positive exponents. Okay. So when it comes to simplifying, you have to switch to rational exponent, because we have rules for exponents, but we don't have rules for radicals. Okay, so first of all, let's switch right away. Okay, so what kind of root is it? What kind of root is it? What do you see?
What do you mean? What kind of root?
Square. It's a square root. Index is 2.
Is the types of root?
It's a square root. You see, there is no index here. So if it's a square root, then which rational power exponent is 1 over 2? Right? Okay. Down, the same thing. Okay, now guys, there is another rule that if you have the same exponent in the numerator and denominator, you can unite this like this over 36m to the power of 10, and all of it to the power of 1 over 2. Do you understand this part?
Yeah.
For example, if you have 2 to the power of 3 and 3 to the power of 3, it's the same thing as 2 over 3 all to the power of 3, okay? So if you have the same power up and down,
I understand.
yeah, good. So now, why did I do this? Because inside here, it will be difficult, it will be easy to do it. Although, you know what? They wanted something else. Now I see that they wanted something else. Sorry, because, why I'm saying this? Because they wanted you to distribute it. Why? Because you can find the square root of 25 and you can find the square root of 36. So let's distribute according to the power.
You can't
25.
find the square root of 36?
We can, yes. And power of this. And then
5 and 6.
This one and this. So we get 25 to the power of 1 over 2. M to the power of negative 12, all to the power of 1 over 2. 36 to the power of 1 over 2. And m to the power of 10 to the power of 1 over 2, okay? So tell me, what is 25 to the power of 1 over 2?
5.
It's a square root 25, right?
Yeah.
What is square root 25?
5.
5. What is 36 to the power of 1 over 2? is the square root of 36. What is the square root of 36?
6.
6. So now I'm going to write 5 at the top and 6 at the bottom instead of the constants. Now, guys, what should I do to these powers? M to the power of negative 12, all to the power of 1 over 2.
Subtract. Oh,
No.
multiply.
Multiply. What is negative 12 times 2?
Miss, can we just 1 second, Miss? I just want to write this down.
Okay, so this is going to be m to the power of negative 6. Now, what is down? M to the power of 10 times half.
5.
5. 5. And finally, I can simplify it. M to the power of negative 6 divided by m to the power of 5. What should I do to the powers?
Subtraction.
Subtract. So, guys,
So
5
negative 11
over 6.
Negative
M to the power of negative 1. 11. And finally, I need to get rid of the negative exponent. So it's
Why did you put the m like?
So
on the
we
side
move
of
the base. We move the base.
Because you can split. This is one fraction. This is the other one,
Oh, okay.
right? So we can do this base, flip it, so it becomes. Just a second.
6/5.
It becomes 1 over m. So it becomes 5 over 6. Sorry, I want to use green one so that it's clear.
What is this? Is this for the answer?
Wait, 5 over 6 times 1 over m to the power of 11. Agree?
11. Yeah.
So all of it is 5 over 6 m to the power of 11. This is the final answer. Okay?
Really?
Yeah.
I
Okay,
thought,
guys. So look, we are done. We're already 1 minute late. So I'm going to pick up specific questions because I don't want them to get too hard for you. I want you to drill everything that we have discussed today. And then tomorrow we'll take more advanced level. So please check my post for the homework, okay? And
more advanced than this, Miss?
Sorry?
More advanced than this?
Yes. Okay, so like this and harder. Okay, so check Google Classroom for homework later on today. Okay. So
okay, thank you, Miss.
I hope it goes well for you the first day of Ramadan, and I'll see you tomorrow.
Have a good day, Miss.
All right, bye.
You too.